Okay, so in this video I'm going to have a look at Dijkstras algorithm, and in particular I'm going to have a look at this particular network here, which could represent any situation, but let's say it represents a map of towns and roads between the towns. The weights on the arcs represent the distance between the towns. So what we want to do in this video is have a look at finding the shortest distance between the source and the sink node. So finding the shortest distance, in other words, between A and H. So in order to do this, I'm going to first replace each of the nodes with boxes. I'll just show you how I do that. So this is it here. So I've replaced each node with a box, and you can see here that each box is divided up into 4 sections. The first box here represents the node label, so we've got A, B, C, D, E, F, G, and H. The second box is going to represent the order of labeling, so A here, for example, is going to be number 1. Down along here we have what's called a working value. I'll explain that as we go along. And here we've got a final value. A has a final value of 0, so I'm going to put a 0 in there. Again, I'll explain that as we go along. So let's start. We're going to look at first finding the working value for each of the nodes from A. So if you look at the arcs from A, there are 3 arcs from A, one up along here, one here, and one down along here. So what we're going to do is we're going to write in the working value at each node for each arc. So in other words, at B here we have a working value of 25, because the weight here is 25 on this arc. It's 25 kilometers, if you like, from A to B, and that has come from A. Down here we've got a working value of 48, again from A, and here we've got a working value of 71, again from A. The next thing you do is you look at the 3 working values. Remember, this node here is complete. I'll just put a tick next to it. These 3 nodes here are not complete. So you've got to look at all the uncompleted nodes and look for the smallest working value. So the smallest working value is 25. So we're going to put that up here. It's going to be 25. That's going to be our final working value for B, and that's going to be number 2. So this is now complete. What you do next is you look at all the arcs from B. So we've got an arc out along here, and we've got an arc down along here. So let's just add 25 plus 21. So that's going to be 146. That came from B. So that's the working value for E. Let's come down along here. We've got 25 plus 26. That's 51. Now 51 is bigger than 48, so I'm not going to include that here in the working value for C, because remember we're looking for the shortest distance from A to H. So I'm not going to include anything bigger than this working value here, 48. Okay, so that's it from B then. So now what we do is we look at all the incomplete nodes. So we've got 146, we've got 48, and we've got 71. The smallest one is 48, so that's the one I'm going to complete now. So 48 is going to go up here. That's our final working value for C. That's going to be number 3. So this is now complete. We now look at all the arcs from C. So we've got one up along here, but this is already complete, so we don't go in that direction. You've got to go out here to E. So we've got 48 plus the arc weight, which is 89. So it's 48 plus 89, which is 137. 137 is smaller than 146, so I'm going to include that here. 137, that came from C. Next thing we've got to do is come out along this direction here. We've got 48 plus 56, which is 104. And again, that came from C. We can come down along this way. So we have 48 plus 67, which is 115. So we put 115 here. Again, that came from C. And finally, we can come down along this direction here. We've got 48 plus 24. This is our 48, and we've got 24 here, our 48 plus 24, which is 72. Now 72 is bigger than 71, so again, I'm not going to include that here. Okay, so let's look at all our incomplete nodes. So we've got 137, we've got 104, we've got 115, and we have 71. So 71 is the smallest. So I'm going to put 71 here as the final working value for D, and that is number 4, node number 4. So that's now complete. So let's go from D then. So from D we've got two arcs. We've got one up here and one here. So we've got 71 plus 32. That's 103. So 103 is smaller than 104. So we put that in here. That comes from D. We've got 71 plus 43, which is 114. So we put that in here. That came from D. And that's it really. So let's have a look at what we're left with. We're left with 137, 103, and 114. So the smallest one is 103, so that's going to be here, 103, final working value for F, and that's number 5. Okay, so that's now complete. So let's go from F now. So from F we can come up along this direction. So we've got 103 plus 32, that's 135, that came from F. We can come out along here to the sync node. So you've got 103 plus 80, which is 183, and that came from F. We can come down along this direction. So we've got 103 plus 76, that's 179. So 179 is bigger than what we've got already, so we don't include that. Okay, so let's see which is our smallest value for our incompleted nodes. We have 135, 183, and 114. So it's going to be 114. So we put 114 up here, that's number 6, and this is now complete. So let's go from G. Well, the only place we can go from G is out to our sync node, which is up along here. We've got 114 plus 67, which is 181. That came from G. And that's it really. So our smallest, now we've only got two left. We've got this one and we got this one here. And it's going to be 137. Which, no, sorry, it's this one here and this one here. So it's 135, 181 and 135, so it's going to be 135. That's going to be our smallest value, our final working value for E. That's going to be number 7. So that's now complete. So all our nodes are complete now except for the sync node. So let's go from E down along here. We've got 135 plus 30, that's 165, which came from E. So 165 is going to be our final working value for our sync node, 165. That came from E, and that's going to be number 8. So we have 8 nodes, so we are correct here. That's fine. So our final working value is 165. In other words, the shortest distance from A to H is 165 kilometers, let's say, in this scenario. And how do we work out the path that we take then? Well, let's have a look at that. We're going to start here, 165. Where did that come from? It came from E. So let's write down H first. And then we went back to E, so we're going up along this way. And then let's look at our 135. Well, that came from F. So we're going to come down along this way now. So let's put an F here. And let's see, we have 103 here. 103 we can see came from D. So let's go along this way and put our D in here. And then let's have a look. D was 71. 71 came directly from A, our source node. So we're coming up along this way. So this is the path we need to take. If we take this particular path here, we're going to end up with our shortest distance, which is 165 kilometers. And that's really it. That's how you work out the shortest distance from source to sync node using Dijkstra's algorithm.